Hi, welcome to Cypress Domes and Floodplain Forest. Today we're going to talk about those very issues. And the first thing, of course, is why is a cypress dome a cypress dome? It's tall, it's very tall in the middle. It actually rises up, becomes dome shape, coming down to the edge. In this case, in Florida, we're actually looking at one that's formed over a sinkhole or a slump that periodically holds water. And in this area where they've done some timber harvesting, we can see a cross section through this particular area. And you can see that the most mature trees are found usually in the center with new recruitment along the edges. Cypress trees are conifers. They do have cones. They have needles. They're unusual in the fact that they shed their needles seasonally. In the wintertime, they'll actually drop their needles in the process of the tree regenerating. Hydrology, the thing that defines actually a floodplain forest, it seems to make sense. But the idea is a lot of what we're going to see is based on the plants. In this case, we're looking at the Hillsborough River. It's a blackwater river. It's not transparent. It's not clear. There are springs along its length. It does have a lot of hydrology associated with agriculture. But the idea is, of course, this river rises and basically drops based on rainflow in those areas and runoff to pick your habitat. So the movement of the water from its containment within the banks to the outside is based on inflows, whether it be rain or releases of water further up the system. And what we kind of look at is the edge habitat. This particular area where the river meets the slightly upper regions, we see some transitional vegetation. This place is pure aquatic. And so plants become one of our best delineators for wetland habitats that are the easiest to see. Obviously, as we saw earlier in some of the presentations, we look at soil, we look at plants in the presence of water, and plants are there around. So, for example, pickerelweed, which we find in these areas, is very commonly found around these habitats in very thick clumps, and you can see the very distinctive leaves and the flower spikes growing up from this particular area. They do have air trapped in the tissues to keep them floating. They're supportive of that. You do find a lot of things associated with those things. Alligator flag, another thing found commonly in those areas. A very, very, kind of beautiful plant that's found in those habitats. Large leaves, whereas duck potato with the white flower actually has a much smaller leaf. It's not quite as prominent as alligator flag. So these are found actually in the aquatic habitat. This last one is actually found a little bit uplands. Sweet gum, one of the more interesting plants, has a very round, very spiked cones on it and an almost maple-shaped leaf. And this is very typical of the vegetation you see. Now, obviously, this is not a plant. This is a fungus. And fungus are very important to these wetland systems because they recycle material. They break down the cellulose. They return the nutrients back into the system again. Swamp milkweed, a very beautiful flower found within the habitat. In this particular case, the swamp milkweed was blooming up in an area that had recently been kind of plowed by the pigs, so they might have actually done it a bit of a favor. But it's a very small, very close to the ground plant. So, and like I said, it is a very typical milkweed. You can see the structure of the flowers, the stems, the elongated stems. This is iris. It's very flattened in terms of the leaf structure. It makes a very beautiful purplish kind of flower on the very top. And then we have maiden cane. It, in this case, is growing up in a sort of a dried wetlands area. It's a very interesting grass. Umbrella sedge grows at a very typical pattern. The idea, of course, is the leaves come out at one point. You see the almost burr-like seed containing. Blue water lily, a very large, showy flower, found prominent along the floating leaves. Notice the leaf shape. And this is in contrast, of course, to the white water lily, where you see a much more rounded pattern and almost lotus-like. When we talk about lotuses, this is commonly what people think about. And a very beautiful, very fragrant flower. Bulrush, found in a lot of places. Triangular stem, small clusters of seed-like areas within this, and this is a very dense thicket of it. Splatterdock, and this is a kind of a neat plant. It's anchored on the bottom. The leaves have a lot of play in them. You can actually see them in terms of their attachment to the bottom through the clear water of the Hillsborough River. Canna, it's a very large plant. The flowers are excessively large. In some cases, these kind of form blockages on the rivers itself. And another one of my favorite plants, lizard's tail. Lizard tail actually grows a very long stalk. It kind of slumps over like the tail of a lizard would be. So like I said, these are often found almost right in the water. Now, also important is what kind of animals. Now, not every animal that we find in cypress domes or in floodplain forests are unique there. Like, for example, the nine-banded armadillo. This guy is found pretty much anywhere he can actually get into, found digging up for different things and scattering. Something that often people mistake for the water moccasin, but the brown water snake, very aggressive, but also a very necessary part for controlling rodent populations, eating fish, things like that. The water moccasin, the one we do worry about, the characteristic lighter head. Lots of variation in color, though, so it's not always an easy snake to pick out. Very dark species and a dark color morph are often, indistinguishable banding. One of my favorite birds in these habitats, obviously this one's in a more urban environment to actually see more structure, but is the wood stork. And in this particular case, the wood stork has actually got its wings out, and it was gathering up a little sun. You can see its very characteristic unfeathered head, the black primaries, the white body, the very long legs. It uses for foraging about. A very good picture here. We can actually see the details of its body and its movement through. So, wood storks are often found foraging in a common area, looking for crustaceans, amphibians, frogs, things like that. White-tailed deer, not indicative of the habitat, found pretty much everywhere in Florida and other habitats we find these, but definitely a part. The possum is the same way. Virginia possum is not just found in wetlands habitats, but definitely associated with that kind of Florida look. And there are tree cavities, nesting areas. Great horned owls, one of the neat owl species you actually find out there, moving very quietly throughout the vegetation and the trees. The turkey, a kind of an interesting bird, found in flocks, usually out there migrating around, trying to stay out of harm's way. Both the idea, of course, it's extensively foraging. Red-tailed hawk, one of the major predators out there, capable of moving around in the very restricted space of this semi-open canopy within the habitat. And a good guy to have around, one of the scavengers, the turkey vulture, picking up all the messes and kind of cleaning up the habitat. So it's a pretty good species to have there to get rid of the carcasses and the extra stuff. And barred owl, very characteristic facial disc, the look it has, often found in there. Now, all of these animals can work in this area because we often associate these floodplain forests with very open habitats. In this case, you're seeing a lot of sable palm. But it's easy to walk around in. There's not blockage there. There's not vine growth. There's no, it's not really muddy. There's a lot of litter in this area, but you can see things move through. In this case, you actually often see the stumps left over from the previous harvesting of the cypress. The canopy is moderately closed. It does have some open spots, and especially if there's been a tree fall, you'll see some areas in particular open to the outside. But like I said, it's not completely closed. Now, a particular adaptation of a lot of the trees in this particular area is the idea of a buttress root to reinforce or support its weight within this habitat by distributing the weight out on an elongated root structure. There's no deep tap root in these. The soil is very anaerobic, and so these plants cannot in particular put down deep tap roots. So what they do is they put out a lot of buttress roots. They put them all around the circumference. They reinforce themselves based on stresses within the system so that they can actually stay upright. But you will actually have a lot of them blown down by storms. Like I said, walking through, not hard. You can see this little area here. It's normally inundated with probably a little bit of water. It's always a good way to see the water levels by looking at water marks on trees, but it's easy to move around in, and you can see that it's fairly open within this habitat. Okay, and one of the things you're seeing here is that often, too, these trees get hit by lightning or mechanical damage, and they form burls where the tree grows out in response to some kind of mechanical damage to that particular thing. And if another tree had hit it, actually would start it. Now, when we're looking at these habitats, one of the things, of course, we have to think about is what is altering a lot of these habitats, what's changing the composition of the habitats. And in this case, it's very simple. One of the things that often disturb these things are the import of the European hog. In this case, we're seeing probably some pigs that have escaped off nearby farms. Zephyr Hills, really close to this area, is famous for the number of pig farms, and these guys get out and they revert. And what they do, of course, is start rooting around looking for, they're omnivorous, so they're looking for whatever meal comes their way. And they rapidly reproduce and begin radically altering the structure of the habitat. Eating anything they can basically move themselves into. They're very adaptable, very quick reproduction animals. And they're in there actually taking out a necessary portion of the food chain, eating a proportionally large amount, removing seeds, removing young plants, taking out things that actually would help the system to regenerate. So it's important to understand that these guys are a very destructive influence. And one of the things they often do is putting in wallows, and they open the soil up to exposure, so some of the nutrients can be removed, and they dig in holes with a little bit of water for some mud to coat their skin with. And so they actually physically root up very extensive areas of the habitat, pushing soil aside. And in this particular case, what we're looking at is that they have been rooting in this area, disturbing the soil, changing the composition, letting opportunistic species root when normally they would be contained by the very fact that it's there. And we see the underlying soils are exposed, there's oxidation occurring, removal of critical seed components there and there. So it's very important that these animals would be removed. They're not really a natural component. We see slumps. These are sinkholes in action. The surface has dropped down The underlying supporting rock has basically eroded away from the acidic water that basically gains a lot of the acidity through the combination with the cypress needles, and it dissolves the limestone and has it drop and retains water. So in these areas we see a lack of vegetation where they've slumped it down. And you can see in this case, this is a very mature cypress area. The trees are quite large. They're quite tall. They're very stable. Their branches are much higher up in the system, and it's very, very open in the understory itself. There's some ferns in here. Commonly, we see several different species. Good guy to have around is Pissalidae. It's a beetle that actually spends a lot of time boring in the wood. It actually helps break it down. Its young live in the wood and move about. They're a very large grub, but these guys can also be found moving about the system looking for a new place to go. And most commonly you can find them in galleries underneath the actual bark of a tree. In this case, this one in particular is on a downed oak tree that's fallen, and so these become little islands for them to inhabit to actually start expanding their population. Okay, now in this case we're looking at some ferns, in this case marsh fern. Ferns are very prominent here. You have several different types, giant leather fern, marsh fern, bracken fern, cinnamon ferns, those kinds of things. And you'll find them growing throughout here. Also epiphytic growth up in the treetops themselves. Several cypress domes in Florida are famous for the number of orchid species that actually grow up there. So these habitats have lots of different layering. There's species not only at the ground level, at the lower, mid, and upper canopy, but in the emergent zone you see a lot of species taking advantage of the fact that they have a possibility of you know, getting a little sunlight that nobody else can get. In this case, the marsh ferns are growing in open patches. Okay, like I said, they're open, but they have to be careful. These places do have, radically variable water depths. One day it could be dry, and after a little bit of rain, we actually have some significant changes in depth. And then this next area you're going to see is, me moving across this area. And if you look off to my left, you can see some of the watermarks in trees that can be quite high. But the water has saturated this area. This particular soil area is impounded some water. There's an impervious layer underneath that's blocking the movement or the percolation of the water down the soil. And as the water sits there, it's going to become more acidic as the needles and the organic material almost brew in it, you could think of it, and start changing composition. So this acidic quality, alters the ability for these plants to absorb nutrients from the soil, because the acids actually fix those particular nutrients in the soil. So you find a lot of duff, or you find a lot of organic material tied up in these areas that can't transition over because it's blocked by the pH differences, the acidic quality of that. And so when we look around, you see also these little tree islands. We see these places that are slightly elevated, a little higher up, sometimes where refuge is, but then just a few steps away, as in this case, this is almost a lake-like formation. There's been probably a major slump down in here, and the water becomes quite a bit deeper. Notice on the surface, as this person is walking through, that it has a lot of variable depth. You have to be very careful. There's a lot of organic material tied up, not only leaves and muck and mire, but actually some stumps and cypress knees. So you always have to pay attention. Now, when we're looking at this particular thing, we have to look at the fact that when we go back to this wood stork, when we talk about these guys, in many cases they're not actually using the innermost habitat, but they opportunistically move back and forth between what's going on here. And so when we talk about wood storks, this would be a species that, although it can adapt to man-made habitats, it may not be as healthy. And in this particular case, this group was foraging in a retention pond. So when we remove its natural habitat, when we remove the things it needs to have, it moves out of those particular areas and starts taking advantage of a much more marginal habitat. It's going to be basically moving into areas where it has much more susceptibility to pesticides, herbicides, and a lot of urban pollutants that actually decrease its reproductive capacity.